Okay, in the last videos we found that what the strategy we have and we are going to follow in the next 30 days. So here we have this front pages video in front page that we have discussed in the last video. Now in the next 30 days we are going to compensate and we are going to publish again and again 3 or 4 videos per day. So to have all these videos in your email or inbox, you have to subscribe our channel that you are getting the link downside. So please subscribe that channel and also please share it on to all friends that you have so that you can also have that. Okay, now we are going to, as we have already told, that we are firstly going to focus on the chemistry, then physics and maths, all these three, because they are going to have the weightage and these are the most hard subjects in these five. If you are opting Hindi or opting any other subject, so in these five you are going to have this particular subjects, little the three subjects little hard. So we are going to how we are going to study. We are going to follow this NCRT. That means if you are of LCSC board or CBSC board or UP board, all these three subjects are written around the NCRT. So we are going to follow the NCRT, the most standard book. Okay. So in this first chapter is the haloalkane. So we are not going to waste the time on the ridiculous things that are not about to come this and very have least probability to come in the examination or board examination. We are going to firstly focus on that particular topic, Heidi, which are about to come and damn sure they are upcoming. So we are going to focus only on that. So this is maybe the revision portion here, or maybe the focusing of exact questions or exact theoretical portion. After ending all the organic portions, we are going to discuss all the important questions we have which have already came in the board purposes or which are about to came, and most probably they are coming in the next coming board examination. So first chapter is a haloalkane. First we discuss with the haloalkane. My suggestion is that please open this NCRT along with the as the video is proceeding on. So I hope you have this NCRT. If no, send buy some PDF or you can download the soft copy also, and links are also provided in our description box. Okay, so please open the first unit for unit 10, that is the haloalkane. Firstly we have to complete the organic portion because this is very easy and these all are linked with each other. So please first watch this video, then the next videos. Okay, so since these all are included and linked with each other, so at the very first unit 10, the chapter is haloalkane and haloarine. Haloalkane is made up of two names, halo and alkane. Halo, that means these halogen group, and alkane means any straight carbon chain. Okay, and second one is the haloarine. Haloarine is made up of this halo and arine. Halo is the halogen group and arine is the any benzene group or any cyclic group like this. Okay, so this is the arine group. So this is known as haloarine. Okay, now we are first focusing on the nomenclature. That is very important because in the board purposes, in the board examination, many times it happens that they only provide the IUPAC name or the name of the particular compound, and you have to follow and you have to draw and you have to follow the path instructed, that you have to react this one with this one. So firstly, if you don't know what the IUPAC name and what the exact compound is, you cannot proceed further on. So you have to focus on the IUPAC. So here you can see that there's only single halogen group attached with the carbon chain. So this is known as monohaloalkane. There's two halogen group, dihalo, with different carbons, and there's three with different carbons, so trihalo. And in same strategy in arine, this is haloarine, monohaloarine, dihaloarine, and trihaloarine. Now, if in the alkyl halides we are thinking about the primary and secondary and tertiary, so if there's a one and only one carbon halogen group is attached with the carbon that have only side alongside with only one carbon additional attached with this one, so this is primary. And now if there's two alkyl group attached with this carbon, so this is secondary. There's, you can see, two alkyl groups, and now there's three alkyl group with this carbon and attached with the halogen group, so this is the tertiary. Now allylic halide and vinylic halide. Allylic, there's a trick with this on, that allylic we always be confused with what the allylic is and what the vinylic is. This is the allylic group and this is the vinylic group. The learning trick is that V stands for vinylic, V stands for little bit homo tone like with. So with means if there's halogen attached with that the carbon double bond, okay, just after the carbon double bond, so this is the vinylic group. And if the halogen is attached with the, there's some distance of the halogen, the double bond, so this is the allylic group. Okay, and same in the same topic, there's we have the benzylic and arylic. We have the benzylic halide and arylic halide. So in the benzylic halide, if the halogen is attached, focus it, if the halogen is attached after there's a bridge with the carbon, that means there's a aryl group, then the carbon, after that there's a halogen, so this is the benzylic halide. And if there's a halogen attached with the just after the this benzyl group, this is the aryl halide. Okay, so you have, most of the time it has the question that aryl halide or benzyl halide, you have to form that. So you should know what the benzyl halide and what the allyl halide is. Okay, now little more nomenclature, one or 2 minute more. First one is the N-propyl bromide. That means N stand for the normal. This is the normal propyl group, and there's a bromine. So no N-propyl bromide. This is the isopropyl if the halide group is with the last carbon attached with the last second last carbon. So this is the isopropyl chloride. This is the common name. You have to focus on the common name. IUPAC name is easy, but the common name is little bit tough. Okay, and this is the isobutyl chloride. Okay, that means here you can see that this is the isobutyl group of, okay, because on the second last this is the this alkyl group, so this is known as isobutyl, and this is a halide, so isobutyl halide. Okay, this is the simple bromobenzene. This is the at the meta portion there's a bromine group, so this is the meta M stand for meta dibromobenzene. And this is the symmetrical portion, so this is the symmetrical bromine tribromobenzene. Okay, so these are the easy names. 1 fluoro, 2 2, you can see 1 2 3. So this is a propane chain, and 2 and 2 2 2 dimethyl propane, and this is the 2 bromopropane. Second, at the second one, this is a 2 bromopropane. You can also name it as isopropyl bromide. Okay, this is a common name. Now we are going to focus only little on the nomenclatures. Okay, this is important: gem halide and vis halide. If there's two chlorine group along with the same carbon, so this is the gem halide. You can see that if there's two chlorine group in the first, very first, this and this chlorine and this chlorine, these two halides are there with the same carbon. Okay, same carbon, this is gem. Okay, and if these halogens are with the other carbons, so this is the vis. Okay, vis dihalide, because there's two halide. Okay, and this is also dihalide. Now this was only the common portion that we would discuss about the nomenclatures. Okay, now you have to discuss about this chapter important things. Very first, you should know a little more about proceeding with this chapter, that this carbon and why this carbon and halogen group always break. There's the polarity difference. This is slightly positive, this is slightly negative, so they are not compensated with each other, not satisfied with each other. They since have some polarity difference, so now they will try to maybe every whatever is happening in the chemistry, that is only for the sake that they wants to gain the stability. So they try, maybe we get stable with another compound, so they break their bonds and try to relocate themselves with some another bonds. Maybe if that bond is more stable than this pre-existing one, so that will be the compound. Okay, so there's some polarity difference, that's why they generally means these bonds are very polar and can be back. Okay, now these are the important reactions, these are the very important reaction, in which the last one is the very important, most important, the last one. I will tell you why this is the most important. Okay, to know this, you have just to follow that. What you have to do at every step, you are going to create the polarities and you are going to assemble which type of polarity every compound will have. As you can see, the first compound ROH plus HX, and there's a compound ZnCl2. Now this is the reagent. What is the work of this reagent? I will tell you. First, provide the, this is the very first that I'm telling you the slow step. Now, and the next one, you have to be little fast. So this is slightly positive, so I'm not writing slightly positive, this is positive, this is negative, and this is positive, this is negative. Now these are not satisfied with each other, so they will try someone else, so be little more stable. But there were, if what is the importance, I'm telling you what is the importance of this, if it was not present in the existing previous compound, so what the reaction is happening, that is always in the water. And water, this is R plus and OH minus, and H plus and X minus. So this will reallocate that, this is like this, that you have to move from Meerut to Delhi, but you want to move from Meerut to Delhi, but you have nothing to move on. That means you have no car, no vehicles, not any path to move there. So how can you proceed? But ZnCl2 here, if you got a path, you got a car, so you'll definitely even try to, let's try to move to Delhi. So they are doing the same. ZnCl2 is providing an ionic path. Providing an ionic path. So they broke in the ions, and now this will try to relocate with this one, and this will try to relocate with this one. So we know H2O is more stable. So the second compound is Rx. So this is the final product. Rx plus ka H2. This is the final product. So I hope you understand why the brackings is, what is the importance of this. This is providing the ionic path in the medium, ionic medium bana raha hai, or and this is the final product what we are getting in the particular compound. So this is happening every time in this ROH plus the NaBr. What you have to do, just replace this Br from this product to this product. And very important thing, that we are not going to focus on the byproducts in the organic compound. No matter, you have not to balance the reaction, you have not to focus the byproducts in any reaction. So this is the ROH and NaBr. So the final product is RBr. So this is the RBr. Just replace the halogen group with the alkyl group, Rx, RCl and Rx again. Okay, now this last one is a very important. Why? In this reaction you can see ROH plus the SaCl2. This is the most efficient process to make the alkyl chloride. Why? The product have RCl, this is the alkyl chloride what we need, and this is the SO2 and HCl. SO2 is a gas, it removed out from the process, and HCl is a solution which again is used here as a reagent to provide some ionic path. Okay, so this is the most important reaction. Now the importance of UV light in this reaction. If the UV light is present, so the breaking is like free radicals, so both will have equal energy, so both can react any of the last carbon. This is and this is, these both are the only two suggestions, two possibilities which the product can be formed. Now if we took the dark one, we have not taken that light, we have taken the dark one, so the reaction will proceed like this. Is the electrophilic substitution. I can show here that this reaction will proceed like CX2. That means we, for the compensation, both of our convenience, we write Cl and Cl. This will break, and this was plus and minus. Anyone will be minus, anyone will be plus. Now very important question which has already came in the board, okay, and as well as competitive exams. So competitive exams for board दोनों में आ चुका है. आप you have to focus it. The question was that in the electrophilic substitution of this group, which one is the attacking reagent? So many of many of you will definitely going to answer that Cl minus is the group, but Cl plus is the group, the attacking reagent. How? You can see here that this is the CH3. Okay, now there's the hydrogen group removed away, H plus and minus. Okay, so the center is minus, so only which one is going to satisfy the minus, so this plus is going to bond with the minus. Okay, so Cl plus is the group who is going to attack at the negative portion. Okay, now another reason, benzene is a very stable compound, so Cl and any arbitrary compound is not going to break this bond, and Cl plus, as Cl minus and Cl plus both were this is the Cl, as Cl is the electronegative compound, so after breaking it should have negative, but this is satisfied because this have negative, but it is not satisfied because it has some positive charge, so it is unsatisfied. That's why have more energy and more can randomly orient with each other. So this is the reacting compound. So this is the final product. This is the question that many times has asked in the completing questions. So we are getting ortho and para will be the major of the compound. Okay, third one is the Sandmeyer reactions. Sandmeyer reaction, in which we make the following aryl halide. We have taken firstly the NH2. This is not the Sandmeyer reaction. This is the process of making aryl halide. NH2, this is amine. We first react with the benzene diazonium sulfate, and after benzene diazonium sulfate, this is the Sandmeyer reaction. We are having copper halide, and we are making the aryl halide with this copper halide powder. So this is a Sandmeyer reaction. Okay, so the important is, Okay, these are not the reactions very important. You have just to focus, you have just to see these things. These are not very important things. Okay. Okay, the important is, okay, this one. This is the SWOT reaction, and this is the Finkelstein reaction. So name reaction, you have, my suggestion is that you should write at the left of your book that this is the name reaction, this is the Finkelstein reaction. Finkelstein, okay. The trick is that in Finkelstein, you are going to press your words or your voice on Finkel, as I'm pronunciation Finkel. So it is coming I. So reaction is with some Ni, means a compound that have ionic group. This I group, this iodide group. And in this complete chapter, we are making alkyl halides. So this halide will be alkyl iodide. Okay. In Finkelstein reaction, what we make alkyl iodide. Okay. So this is the group. And in the SWOT reaction, we make alkyl fluoride. The second one is the SWOT reaction. Okay, in this we make the alkyl fluoride. You have to learn these name reactions. Okay. Now there's nothing important in these all. Okay. Now the very important is the SN2 and SN reaction. So you have to see our next video for the SN2 and SN1 reactions. I hope till this you have focused very clearly, and for the next video you have to subscribe our videos, our channel, for the next one, in which we are going to again discuss this complete chapter and this example, very important example. So I hope you are going to watch our next video. Till that, thank you.